Okay, good morning, everybody. So the quiz one topics are on queue now. So if you look at the announcements, you'll find this announcement here. So remember, there are two quiz dates next week. One of them is for students whose last name is A through K. The other one is for the students whose last names are L through Z. Now, when I say last name, I mean your last name as it shows up on OnQ. Right, so there are some of you whose last name and first name, or your last name is actually your first name is your last name as far as Queens is concerned. Please use your name as it shows up on OnQ and not the way that you're used to using your name. The test will be in here. I know you've only got the little platforms to write on. If you want to, bring a clipboard or something, or I guess a big laptop that you can write on. It's on paper. So you'll be writing in pencil or pen, I don't care which. Don't write in red pen, that's annoying. But otherwise it's fine, pencil or paper. Sorry, pen or pencil. And the topics are here. So I've decided not to include anything related to making classes that are used to generate objects. Right? So you only need to know up to the second list lecture, and that is where the material will come from. If you're reading the notebooks are more comprehensive than the lecture slides, but the testable material is that which comes from the lectures. Right. There is a previous quiz that's on OnQ, or has been on OnQ since the start of the course. That'll give you a good idea of what the scope of the quiz will be. Right. Yes. So I'm never going to ask you about a scanner. Okay, any questions about the quiz? All right. Oh, question? Either. Yeah.
When we're writing cont on the quiz,
yeah.
Are we allowed to import anything?
Oh yeah, don't worry about import statements and stuff on the quiz. Those aren't, I don't think that's important for the purposes of a test, okay. Right? So I don't care if you know what the actual full name of the class is. That's not something I think is important to test you on. Similarly, small syntactic errors are not that important either, right? If you're missing a semicolon, I don't care. However, you do need to call the correct method or look at the correct field when doing things like getting the length of a string or getting the length of an array or getting the size of a list, right? If you mix up using an array and a list, and an array list, that's considered to be a significant error, right? So if a question asks you to do something with an array and you do something with an array list, you're going to get a very low mark on you're not going to get a high mark on the question, so you will get penalized for that, right? If you try to use an array list and you're using square brackets, that's a significant error, right? It's demonstrating that you don't know the difference between an array list and an array. Yeah. No, I don't. I generally do not ask multiple choice. I generally do not ask true false. If I ask you a knowledge question, the expected answer is a few words or perhaps a sentence, maybe 2 sentences at most. Right? So they're short answer type questions. The sample quiz shows you exactly what kind of questions I ask. I think it's like 30 or something like that, 30 or 40. It's going to be 30 or 40. It's always something like that. Any other questions? Yes, at the back. Sorry? Okay, so I mean, that's just there as a temporary placeholder. If it's out of something else, it'll be out of something else. I have to adjust it later on. So why do you care what it's marked out of? I don't understand. Like, what difference does it make if it's marked out of 1,000 or 10 million or 20? Yes? Okay, well then don't read don't look at the introduction. You need to know the basics of the Java language. So if you come and write a Java quiz and you're writing Python, you're going to get 0. It doesn't mean anything. It just means you need to know how to write Java. It means you need to know how to write Java. Any other questions? All right. so on to the lecture. We were talking about unit testing in the previous class. And I was talking about this thing called JUnit. So just to quickly remind you, JUnit is a unit test framework for Java. Similar frameworks exist for many other programming languages. So you might come across the term XUnit. XUnit just means unit testing framework for other languages. Right? You can unit test in, I guess, pretty much any language. Can you? Pretty much any general purpose programming language you can unit test in. And so the definition of a unit test is a test that you write for the smallest piece of code that you can actually run. Right? So the smallest piece of code that you can run in Java is more or less a method. So unit tests in Java are generally testing methods and constructors. All right, so remember back in week 1, I showed you this silly implementation of max2, right? So max2 finds the max of 2 values. It's broken because of overflow, but it appears to work in many cases, right? And so I would like to show you how to write a unit test for this kind of method, right? Now this method is it's a static method, right? All it does is return an int, and so it's relatively easy to write a unit test for this kind of method. When you're making unit tests in JUnit, you have to import the JUnit classes, you have to know where the JUnit libraries are located, and so on and so on and so forth. In Eclipse, everything's built in for you. So it's pretty easy to generate these tests in Eclipse. Right? So there's my class max2, it's got my method max2 in it. Right? To make a unit test for this thing, you just go into File, and do, File, New. Stuff like this is also not on the quiz, right? I don't care if you know how to use Eclipse. Right? JUnit test case, right? Press enter. In this course, we use JUnit 4. There is a JUnit 5. JUnit 5 makes extensive use of features of the language that we don't cover in this course. So it's very awkward to use JUnit 5 in this course. So we're going to use JUnit 4. It's still a completely functional unit testing framework. And this works the same as everything else. It asks you to make a class for your tests. So that's fine. You can use the default name. You can give it some other name. It doesn't matter. Right? You've got a bunch of options here. We're not going to use these options in the course. They're useful if you're writing more advanced unit tests. Right? Once you do that, just click Next. It'll ask you what class do you want to test, which methods do you want to test. If you want to, you can go ahead and click something. So I want to click max2, so I'm going to test the max2 method. Right? I'm not going to test the methods in object. Somebody else has already done that. Right? Finish, and it spits out a class for you. Right? So it imports some JUnit stuff for you. It makes a class. It sticks in a method, and it puts this funny tag here. Right? So this is called an annotation in Java. So anything that starts with an @ that's not part of a Javadoc comment is called an annotation. Right? Annotations are used, they allow external tools to do something with the code. Right? So @test tells the JUnit framework that this is a test method. So it needs to be able to run it. JUnit is able to run this method on it as a unit test. So that's all that means. Okay, so the implementation says fail, not yet implemented. Right? And so the method called fail is a JUnit method that automatically fails the test. Right? So if we run this test, so you can just run the test by pressing the run button up here. You'll get this window popping up somewhere. I'll make it a little bigger so you can actually read it. There we go. Right, so over here you see that it ran test max2. Up here is a summary of the tests that were run. Okay, so up here it tells you that 1 test was run. There were no errors. There was 1 failure. Right? Obviously, you want to avoid errors and failures. And over here, there's a little diagnostic message, right? It tells you that this method failed because, the test failed because the test is not yet implemented, right? And it even tells you which test failed there, right? So now you can go and look in the test, in your test method and find out which method failed, right? And it's that one there. All right, so to test max2, the idea is max2 is going to return some value, right? If I run it with some arguments. So if I pick some arguments to run the method with, choose some arguments, right? So I need to pass max2 two values, right? So I'm going to call them x and y. And for your first test, it really doesn't matter what values you pick, right? You just want to write a test. You just want to write a simple test case to see if your method actually does something useful, right? So let's do 10, right? Okay, I've got my arguments now for my method, right? Given the arguments, you need to determine what is the correct output of max2, right? So in other words, I need to know what is the expected value that is returned by max2, right? So define the expected return from max2, right? So what is the expected value? Well, the max of 1 and 10 is 10, or y. So int expected is y, right? So I know, so now I've basically got my test set up, right? I'm going to run the method using x and y, right? I'm going to remember what the return value is after calling the method, right? So call max2 and remember. So I'm going to call this got, and I'm just going to call max2. Like that, right? And now the idea is simple, right? I know what the expected return value is. I know what max2 told me the value was. I'm just going to compare the two and see if they're equal. Test if exp equals max2. Right? And so the way you test this is you tell JUnit to test it, right? So JUnit has a bunch of methods in it that can test for certain conditions, right? One of the, well, a family of methods that JUnit has tests for equality. And so the method is called assert equals. Right? Okay, now when you call assert equals, you pass in two values that you think should be equal. When you pass in the two values, the first value is always the expected value. Right? If you reverse the order of the two values, then your error messages are all incorrect. Right? Your error messages will say, I expected the, and it'll say the wrong answer, but it got the correct answer. Right? So your error messages are wrong if you reverse the order of these arguments. So it's always expected first. It's always the actual or the returned value second. Right? And that's it. Right? So that's the pattern that you're going to use to write more or less any test in this course. Right? There are other things that JUnit can test for that is not necessarily equality. Right? For the purposes of this course, that's not important. Right? If you want to know how to do that, you just go and look at the JUnit documentation or look for JUnit examples, and you'll find all sorts of examples on other things you can test for. Right? So once you've got your test written, you just go ahead and run it. And here, you get the green bar, which is good, right? It said you ran one test, no errors, no failures. Everything's green over here, right? You're looking for green. Green means good, right? It means you passed your test. And that's fantastic, right? So that's great. So there's your first JUnit test case. Okay, so we know max2 is busted, right? We know max2 has overflow bugs in it. Obviously, this test isn't testing for whether or not the overflow is happening, right? You might not even know overflow is happening if you can't see inside the max2 method. Right? So in other words, if someone just gave you some pre-compiled Java code and told you there's max2 in it, right? Please test it for me, right? You wouldn't necessarily know that you should be looking for overflow. And in fact, you would never expect to be looking for overflow in a method like max2. Right? But we know that overflow might happen. Right? So to test the case where overflow is occurring, we should write a test for that. Right? And so how do you write the test? Well, you just repeat all of this all over again. Right? So I'm just going to copy this and change some values. Right? So give it a new name. So I'm going to call this text max2 for overflow. All right. So when I want, if I want to force overflow to happen, one way to do that is to make sure x and y are very large. So let's do that. So I'm going to make x equal to 1 billion. I'm still going to leave y the larger of the two values. Right? And we know that integer max value is roughly 2 billion. So if I add those two values together, that's 3 billion. That should definitely overflow. Right? Everything else stays the same, right? My expected maximum value is still y. I'm still going to call max2, and I'm still going to compare whether or not the expected value matches the return value. Right? And you run that. Right? And now you get a failure, right? You see the red bar, so that indicates that something has either, one of your methods has either encountered an exception of some kind, so those are your errors, or it's failed its test. And in this case, it's failed its test. Right? Probably hard for you to see, but one of the tests is marked in blue. The other one that passed is marked in green. Right? So there's a little blue X up here, and it tells you what the error message is over here. You make the window a little bigger. There we go. Right? It says there's an assertion error. It expected 2 billion, but the answer it got was minus 1,474,000,000 and something. Right? And so now you realize, oh, there's something wrong with max2. Right? And now you go and debug max2 and try to figure out what went wrong. Right? And so that's an example of, there's a second example of writing a unit test in Java. Sorry, with JUnit. Right? When you write your unit tests, right, you keep all of the previous unit tests that you've written. Right? So you could have just replaced 1 and 10 here with 1 billion and 2 billion and just had one test method. Right? But you want a record of the tests that you've actually run. Right? So you generally should not remove tests that you've written before. Right? You want to reuse those tests when you to continuously test the method that you're developing. Right? And so it's not unusual to see these test classes that have many, 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 many tests in them. Right? Okay, so this, if you go back to the lecture, you'll see some important stuff back here. Oh, here we go. Right, so there was this quote back here that says, program testing can be a very effective way to show the presence of bugs, but it's hopelessly inadequate for showing their absence. Right, so you can't, it's very difficult to prove a method is correct by using testing. So for example, max2, how would you prove that max2 is correct? Right? So the answer is via testing. The answer is you would use every possible value of x and every possible value of y. Right? For this particular method, that might be feasible. Right? So there's 2 to the 32 possible values of x, there's 2 to the 32 possible values for y. Right? I guess if you multiply those together, that's 2 to the 64. So that'd probably take a long time to test all of those, all combinations of values. Right? If you insert another parameter in here, right, now it's 2 to the 92. So you're probably not ever computing that in any reasonable amount of time. Right? And so on and so on and so on. Right? So testing, or exhaustive testing, can prove that something is correct, but usually you cannot exhaustively test a method. There's other problems as well when you're testing. Right? So I've got these tests here. The problem with testing is that you have to write code. Right? You have to write the test code. And so if there's a bug in your test code, right, your test is now misleading. Right? So if there's a bug in your test code, it might be the test itself that's incorrect rather than the method that you're testing. And so that's a problem. That's a big problem for new programmers because new programmers aren't particularly good at writing code yet. Right? And now they have to write this unit testing code. And it's not unusual to see bugs in unit testing code. Right? And so you end up with this problem of who tests the tests. Right? And then who tests the tests that test the tests, and so on and so on and so on. Right? And so generally it takes a reasonably experienced programmer to actually write these tests. Oops, sorry. What's going on here? Okay, so that's a tester max2. So just in summary, when you write a test, basically what happens is you decide how are you going to call the method, right? So what arguments are you going to use? Right? You need to determine what is the expected return value when you call the method. Right? Now, some methods don't return a value, right? So some methods especially when you're working with objects, some methods modify the object. So you have to determine some way to test, was the object modified correctly, right? So I'm going to show you an example of that in just a second. If the method returns a value, though, you need to determine what is the correct return value. And then you want to compare the return value to the actual value that's returned by, to the expected value. And this is another problem here, right? Determining what the expected return value is. So for all the methods that you see in this course, you can normally figure out what the expected return value is, right? But there's a lot of methods that you might encounter where it is very difficult to determine what the expected return value is, right? So for example, if you were to test some of the math methods in the math class, right? So for example, some of the methods that involve raising e to some exponent, right? If you wanted to test those methods, you need to figure out what is the value of e raised to the exponent, say 2.5, right? And you can't, well, you probably can't work that out on pen and paper, right? And so determining what the true return value is for a test is not always easy, right? Often it's very difficult. And so that's another problem with testing. You need some way to determine what the correct value is, and that's not always possible to do, right? All right, so if you progress through the computing science program, and in particular, if you take the software engineering courses, you're going to encounter testing quite a lot, right? And so you'll be told, you'll encounter the term test case, right? So for our purposes, a test case is the arguments that you're going to use to run the method, right? And the expected return value or the expected results when the method is called with those specified arguments, right? In your tests, you call the method with your test case arguments, you record the return value of the method, and then you test if the actual return value equals the expected return value, right? We're always using assert equals in this course. Again, there's a bunch of methods called assert something in JUnit. And there's many extensions for JUnit that let you assert very general conditions are true. So there are surprisingly powerful tests that you can write. But we won't encounter any of those in this course. Okay, so let's test a method that belongs to a class. That belongs to an object, I guess. So remember the counter class has this advanced method in it. So let's test advanced for the counter class. So I'm going to make a new JUnit test case for the counter, right? We can just accept all of the defaults. I want to test advanced. So JUnit produces a skeleton test program for you, right? Okay, so to test advance, right, this is a little bit different, right? So I want to call the advance method, but to call the advance method, I need a counter. Right? So when you're testing methods that belong to objects, typically you have to create an object, right? And you want to create a counter with a known starting value. And so for a simple test, you could just make the default counter, right? So just call the no argument constructor, make a plain old counter, right? So advance has no input, has no arguments, so I don't have to define any arguments, right? But I do know that if I advance the counter once, the value of the counter should become 1. So here I need to define the expected value of the counter after calling advance, right? So that's going to be, so the current value of the counter is 0. If I call advance once, the expected value is going to be 1, right? Call advance, right? Advance doesn't return a value, so I'm not recording the return value at all, right? So now what do I need to do? Now I need to compare the current value of the counter to the expected value, right? So compare the current right. Okay, so how do I get the expected value? Well, I call the counter's value method, right? So int got, right? And now finally use assert equals, to assert that the expected value is equal to the returned value like that. Okay, so save your edits, run the class, run the method, and the test passes, right? Everything's green, so we're good. Okay, let's go back to the counter, and let's break our counter method. Okay, so that's the correct version of counter, of advance, sorry. Let me break it by putting in the incorrect implementation. Okay, now the funny thing with the advance method is that that implementation of advance is wrong, but it's almost always right. So if I run this counter test, it's going to pass, right? So it still passes, right? And so this illustrates another problem of testing, right? Testing only reveals the errors that are encountered for your test cases, right? Sorry, for your test cases. So this particular test method is only going to determine, will only discover errors in advance if you advance a counter whose value is 0, right? It's not going to determine whether or not there's an error if you advance a counter whose value is 1 or 2 or integer max value, right? And so one of the big challenges in testing is that is how do you determine what your test cases are, right? And so there's a whole art. It's not really, well, there's a whole art, and I guess there's some science to it, that provides guidelines on what values you should choose when you are writing your test cases. Right? I'm going to leave that for your software engineering courses, because that's a fairly large topic. I don't know if there may be, I don't know if Queen's has an entire course in testing or not. It is possible to take university courses where you talk about nothing other than testing, though. So I'm going to write another test case to actually expose the error, just to show you how you would do it. Right. So again, this is going to find the, oops. Again, we're looking for the error that occurs when the counter overflows. Right. So to reveal this error, I'm going to start the counter at integer max value. Like that. Right. So I know that if I advance that counter by 1, I should get back 0. Right? And now with our incorrect implementation of advance, this should reveal the error, and it does. Right? And you can see that the expected value of the counter is 0, but we're getting back this minus 2 billion and something. Right? And so that test case now reveals the error. Okay, so I guess just to a few comments on how do you pick your test cases. If you can see inside the method, right? So if you're actually able to see the implementation of the method, it becomes easier to pick your test cases, right? If you look inside advance and if you remember some stuff about overflow, right? You can kind of guess that advances might fail when the overflow condition occurs, right? You can kind of tell because there's an if statement here, right? So based on the if statement, based on the condition of the if statement, you can guess at good values to use for testing. Right? Here we can see that even though the if statement is incorrect, right, something funny happens at integer max value. Right? So that suggests that maybe integer max value is a good test case for this particular example. Right? And that is in fact the case. If you can't see inside the method, testing becomes much harder. Okay, so there is this whole process. So I guess somewhat surprisingly, the practice of testing, the practice of writing tests to actually drive the development of software is fairly recent. Fairly recent, I mean like in the last 30 years or so. And people have been writing software for much longer than that. So there's this thing called test-driven development. Right? And so in test-driven development, the software development process is heavily dependent on writing tests, and more importantly, writing tests that are automatically run. Right? So if you go to work for a large-ish company or a company that uses test-driven development with more than one person in it, right? Typically what happens is that there is a central repository of code somewhere, right? Whether it's up in GitHub or if it's on your company's local server somewhere, or I guess someone's computer somewhere. There's a central repository for your source code, and all of the developers will pull from that central repository, right? So they'll grab the code from the central repository, they'll make changes to it, and then they'll upload their changes to the repository. Right? It's possible to set up a modern software environment, a modern software development environment, so that when you upload your code to the repository automatically runs a bunch of tests. Right? If your code that you upload fails any test, then the upload fails. Right? And so you can't actually make changes to your, you can't make permanent changes to the repository without ensuring all of your existing tests pass. Right? And so the way that test-driven development works is you're going to write some you decide, I have to write some software. Right? You figure out exactly what is the software is supposed to do. Right? Before you write the software, you write the tests for the software. You don't have to write all of them, right? But you need to write some of them, at least one. Right? So imagine you say, well, I need this class, it has to have this method. So before you write the class and the method, you write a test for the method. Right? You run your test to make sure that the test actually runs. It should fail because you don't have a method yet. Right? Now you write your code. Right? You run your tests. Right? If any test fails, you fix your code and you go back and run your tests. Right? You fix your code. If it fails, you go back and run your tests, right? And so on and so on and so on, until the method that you're writing actually passes all of its tests, right? Then you go to the next method. So you write a test, right? Run the test. That test should fail because you don't have the method yet, right? Write the method, repeat the process all over again, right? And so the tests actually drive the development process. You have a question?
I know it might be, I guess, more of a joke, but I've also heard a lot of times that the test fails. The tests?
Sure.
Does that happen a lot?
No, well, it shouldn't.
It shouldn't happen.
It shouldn't happen at all, right? And if you end up working in a place that does that, you should find a new job. So that's the advice I have for you. So no, you want to make sure that all your tests pass, right? They're there. If a test fails, it's telling you something, right? Your software is wrong. I guess for some types of software, you might accept failing tests, right? A lot of video games, for example, will fail many unit tests if you ran them, right? But for, important software, hopefully all software, you want to make sure all your tests pass, right? All right, so that's test-driven development in a nutshell, and that's how you write unit tests. If you're wondering how your assignments get marked with the help of unit tests. Right? So the TAs get a bunch of unit tests that I've written. They run the unit tests, and then they're told they should go in and debug your code, but they don't always do that. I should tell you, there's a bunch of problems here with testing. So testing student code is very difficult, right? So let's look at that counter class again, that counter test again. Right. So the problem with this advanced method, testing this advanced method, is that it relies on two things being correct. So it relies on a bunch of things being correct, right? So number one, the test has to be correct. Okay, so let's assume the test is correct. Number two, I have to make a counter. And so this requires that the counter constructor be correct, right? And then I'm testing advanced, so I don't know if it's correct or not. But then there's this value method that I have to call. So the value method also has to be correct, right? If the constructor is incorrect, or if the value method is incorrect, then there's the test is not going to, the test may or may not, the test is going to be unreliable, right? If I can't reliably create a counter, I can't reliably test the counter, right? If I can't reliably get the value of the counter, well, I can't test the counter again. I can't reliably test the counter, right? So when you're marking student code, especially students who are new to Java, right? Often there's a mistake in the constructor, right? And that means you can't test any of their methods reliably, right? Because you can never make an object correctly. And so the instructions that the TAs get is that they should fix your constructor. If they don't, though, then all of the tests are going to fail, and you might get like 0 on the assignment, right? All of your code might be correct except for your constructor, right? So you should get a high mark on your assignment, but because the TAs sometimes over-rely on the unit tests, right? You may get funny results on your assignments. Right? It is very difficult to write tests for student code, right? Because students will write all sorts of stuff that I would never expect. And it's very hard to write tests that can cover all of those cases. All right. Any questions about testing? Super. So let's move on. So we're going to go backwards now, which seems a bit strange. I'm going to go back and talk about static stuff now. So at the beginning of the course, I told you, look, everything in your classes is static for the time being, right? And so you had methods that were static, right? You can have fields that are static in the class, right? Anything that's static means that it's associated with the class and not with individual objects, right? So a field that is static means the field belongs to the class, right? And so we say it's a per class member, right? In other words, there's one variable, there's one field, it belongs to the class, right? So any object that's created using the class, right, does not get its own copy of the static field, right? All of the objects share the same static field. And so static fields are sometimes called class variables, right? The word class here is to indicate that it belongs to the class and not an object, right? Non-static fields are sometimes called instance variables to indicate that they belong to individual objects and not the class. So an example of a static field is going to come from this little domino class. If you don't know what a domino is, so domino is a family of games that's played with these things called domino tiles. Right? Each tile has two sides, right? They're marked with a number, or more correctly, they're called pips, right? And so you can have up 0 or 6, up to 6 pips on each side of a domino. Right? And there's all sorts of games you can play with these things. So if I wanted to make a class that represents a domino, that lets you represent a domino tile, it might be useful to know what is the minimum value and what is the maximum value for one side of the domino, right? And so we can make a field called min value and a field called max value, and we can make them static, right? So why are we making them static? Because the minimum value and the maximum value doesn't change for each domino piece, right? The minimum value and the maximum value is the same for all dominoes. So it doesn't make sense to have a min value and a max value field for every domino object. One will do, so we make it static. Right? The keyword final means that this variable can only be assigned to once. So if I create the variable and assign at the point of creation, then it's been assigned a value. That value can never be reassigned, right? So min value and max value are effectively constants in this class. Right? If you have a constant, so if you have something that's static and final, generally you write it, the name in all caps, right? So now you don't use the Java convention of lower camel case, right? It's in all caps. It's written in all caps to indicate that it's supposed to be a constant value. Right? Furthermore, we can make it public so that everybody can use min value and max value. Right? Anybody using the domino class might want to know what is the minimum and maximum value of a domino. Now, every domino piece, every domino tile has two sides. Right? So we have two more fields, val1 and val2, that represent the two sides of the domino. Those cannot be static. Right? If these were static, then that's saying every domino has the same two values. Right? So every domino that you make would have the exact same value 1 and 6, the exact same value on both sides, would have the exact same value 1 and the exact same value 2. Right? So these must be non-static. Right? If you look at a memory diagram of this thing, right? So I make two dominoes. So there are my two domino objects. Right? Notice that each domino, they have their own copies of the non-static fields. Right? So domino, D1 and D2 both have their own value 1 and value 2. Right? They don't have min value and max value. Right? So these two objects do not have a copy of min value and max value. Instead, min value and max value lives in the domino class itself. Right? Okay, so when you're using a static field, when you're using anything that's static, you access it using the name of the class. So if I want to use min value, I write domino.min value. Right? Unfortunately, it is legal to use a domino object to access min value. Right? So for example, I can make a domino object here, and then write d.min value, and I still have access to the field. Right? You should not do this, even though it's legal. Right? The problem with writing that is that any Java programmer that looks at this is going to think, or is going to initially think that min value is a non-static field, right? Because you're accessing it using an object reference, right? And that's confusing. That is initially confusing, right? An experienced programmer is going to look at this and say, hey, that's a constant. It's written in all caps. It's probably a constant. So whoever wrote this is being impolite, right? So it's considered bad form to write something like that, right? If you're accessing something that's static, always use the name of the class to access it. Right? Anything that's final can only be assigned to once, right? So public static final fields are typically assigned when they are declared, right? It doesn't have to be, right? So you don't have to write the equals 0 here. At some point, you have to say what min value is equal to, but it doesn't have to be here. Right? Usually it's here though. Right? If you have anything that's public, static, and final, right, the fact that it's public means it's important to the class, right? So in other words, it's meaningful, right? The fact that it's static and final means you are essentially saying this thing is a constant, right? Or at least that is, that's basically what you're trying to convey, right? Now you have to be careful with that because these aren't necessarily constant. Yes? Can't be any assortment. I forget exactly what the rules are, but we can find out very quickly. So I'm just going to stick in a public static field into the sum class. So public static final int x equals 1. Okay, so now I'm just going to experiment. So can I move? So I think the public has to, is that true? I think the public has to be first. I think the access modifier has to be first. Is that true? No, it's not. So that order doesn't matter. So can I move final somewhere else? I guess it's happy with all of those. So the answer is no. I think the modifiers can show up in any order. But sorry? No, the int can't. The int has to be in front of the variable name. That I know. So the compiler doesn't care, but the convention is public static final. So it is access modifier, static or non-static, and then final or not final. So that is the convention, but I guess the compiler doesn't actually care. Okay, so if you have a primitive type and you mark it as being final, then it really is constant, right? So final means I can only give it a value once. It's given a value here. If I try to reassign it, the compiler will flag that as an error. Right? So if I try to write domino min value equals 100, the compiler will say, hey, you're trying to reassign a final value. Right? So that's good. So that really is a constant. If you have an immutable reference type like string, then it's also constant. So remember, string, once you make a string, you can't change the characters of the string. Right? Further, you can't change the length of the string either. So the string peekaboo is always the string peekaboo. Right? X, because it's final, always refers to the string peekaboo, right? So in this case, x really is final, right? Sorry, in this case, the string peekaboo really is a constant, right? If I try to write nothing to hide .x and reassign a different string, right, that won't work. Again, the compiler will say, hey, you're trying to reassign a final value, right? And string is immutable, so there are no methods that can change the contents of the string. The problem comes when you create a final field of mutable type, right? So here I've got a list of string that I'm calling empty, right? And I'm making a new array list object that empty refers to. Right? The name empty strongly suggests that this is always the empty list, right? But that is not the case, right? Empty is a list, so it has an add method. Right? So I can call add on that list and add a string to the list. And your empty list is now no longer empty, right? Which is confusing, right? The name says empty. It should be an empty list. It's not an empty list, right? So if you have a mutable reference type, right, you have to be very careful if you are making it public if you're making it public and static and final, right? It looks like it's a constant, but it's not, right? It's not logically constant, right? So yes, empty always refers to that list, right? I can't make empty point at another list, right? But empty is not always the empty list, right? I can still add stuff to this list. Yeah.
Is it good? Sorry, if you just declare a final variable
Yep.
at the very top, and in the method you declare it as a value, that if you exit out of that method, it'll still be you can reassign it again.
Okay, so here I've got public static final int x equals 1, right? I think what you're asking is can I make a variable here also called x? Is that what you're asking?
Can you assign that variable, x variable to a value, and then afterwards, outside the method, assign it another?
No, it's final. So if I've given it a value once, I can't give it a value again.
I mean, like, if you don't give it a value.
Oh, if I don't give it a, yes, okay, so don't give it a value. Here, I can give it a value. So counter x equals 0. That should go, so is it still flagging it blank, final? Oh, yeah, it's fine. I don't believe that is in fact the case. So this is flagging that as an error. I don't think that's, it's complaining down here. Cannot be assigned, okay. How do I forget what the syntax for this is. There's something called the static initialization block. That should be, okay, so that is allowed. So that, I guess, assigning it a value inside the constructor or method is not allowed if it's marked as being final. But you can, there is another location where you can initialize the value. That thing there is called the static initialization block. So it's a block of code that's used to set the value of static fields in the class. So you can write stuff like that. If you need to write code to set x, right? So imagine you need to write some complicated, well, not necessarily, some more than one line of code to actually compute the value of x, you can do it here. Yeah.
Make that a final static initialization block code?
This thing here? Yeah. No, so the final modifier does not apply to the initialization block.
Is it possible to initialize x with something complex and then say, okay, now this is final?
No, you can't make, it has to, the final applies at the point of declaration.
What you have to do is at the end of the initialization block, make a new variable that's the final and assign it the value of x. Something like that.
There's no need to do that, right? So here, x has no value, right? It's not until the initialization block runs that it has a value.
Oh, so if you have a final that doesn't have a value, the first time it gets the value, that's the value.
Yeah, yes, that's correct. Yeah.
It's not just final as no value.
No. At some point, it needs to be assigned a value. Yeah. Okay, what time is it? Okay, that's a good place to stop. So we're going to talk about static methods in the next lecture.